Hello and welcome to this short talk about a brief introduction to cross-site scripting. This is Jens from SecurityValley giving here the short introduction, and therefore I have prepared not that usual kind of boring alert example, Instead, I've created a whole application here in Angular with a Go backend and created kind of real project requirements that we cover and that have lead to a major security flaw here. So therefore, warm welcome. Do a short preface. As usually, this is not a hack your friend's Facebook account tutorial. Keep that in mind. I try as good as I can every technology stuff that appears here in the slide. But if I mess something up, I'm sorry. Just reach out to me, correct me. You got a point. What is the motivation behind that? I'm still convinced that a best defense is usually a good offense. So know what can go wrong. Know how potential enemy attacker, call it whatever you want, looks at your application, makes you a better software engineer, or increases your software quality. So, short overview. Have 3-4 bullets intro. Then I'm sorry, but we need to talk a little bit about theory, some terms and all that stuff, like content security policy and all the other stuff. Then I've prepared a real background story so that we can jump in right into a story and hack our way through. So then obviously we will jump into the hacking time. There's an outro slide where you see again ways to get in contact with me, and hopefully we heard that in the future. So short intro about me. I work kind of red teaming, coding, trainer about that stuff. I'm totally convinced about the open source movement and all the stuff that is related to that. So that's one of the base motivations behind those talks here. I think knowledge should be free and accessible for everyone. So enough. Let's start with with XSS. At first, XSS is an abbreviation for cross-site scripting. What a surprise! Usually, you see that in the context of JavaScript. There are other languages, techniques, stuff, but it's out of scope. The goal within the JavaScript or the cross-site scripting is usually to inject something, and the something is a piece of JavaScript that gets executed, hopefully, on the victim's client or on the victim's browser, so to say, and obviously in his web application. Usually, you have something bad in mind that can be to steal credentials, sensitive information, usually with the goal to impersonate another user, usually kind of an administrator or a higher privileged user, so to say. A little bit theory. I do that as fast as I can. If you talk about cross-site scripting, you need to understand how the web browser is handled, the web page. So you have usually 3 ingredients, so to say: the HTML, which is the structuring of your web page. That's the hypertext markup language. Then you have the cascading style sheets that's used for positioning and styling these HTML elements. And then you have JavaScript for interaction, to make buttons interactive, to fetch data from a backend, send data around the browser, so on and so on. That are the 3 major pieces that you have. So all that together, we can think like an attacker. What is maybe an interesting goal. If we talk about login systems, we usually talk about cookies or at least a layer of storage or storage layer in your browser. That can be your session storage, your local storage, your cookies, whatever. The thing is, how can an attacker maybe access that storage layer and steal information that are stored on that layer? So for example, if you have your Firefox, do username password to, for example, a Facebook application or a backend application, then maybe the backend is answer you with a token. So for example, a JWT token, which is signed and it's stored either in your session storage on your in a secure cookie, for example. Then you use that as an artifact for authentication, so to say. So that is enough theory. Then we need to clarify some terms. The first absolutely important one is the origin. So what does it mean? Origin is a combination about the protocol, the domain, and the port. So for example, HTTP is the protocol, then test.com is the domain, and the port here is obviously because that it's HTTP, it's 80. The same is for HTTPS, is 443 for SSL. And if you see HTTP, test.com and the SSL version of test.com are not on the same origin. That is crucial to know because they differ in the protocol, at least they also differ in the port, right? The same is here with HTTP test.com on 8080 and the other port here with the other origin. So that's the first brick that you need to keep in mind, or the first major term. Then I think everyone during development time has always facing the CORS or the cross-origin resource sharing problem, in quotes, because it's not really a problem. It's kind of a configuration or works as configured stuff. In the end, it's a policy for interaction with other origins that should prevent, or the idea was to prevent the browser running stuff or code or assets from another origin. That it's usually a server-side restriction that you can configure, where you can say, okay, I only allow access from origin A, B, and C, and all the others get a rejection. So, for example. But it's more or less on the server side stuff. But it's crucial that you have heard that and that you keep that in mind. The last brick here is the content security policy. That it's a header that it's usually enforced by the server. You can set that programmatically within the meta tags, if I remember correctly, in the HTML. But it's a good behavior that the server is always enforcing that. So for example, let's have a look at our demo application. So therefore I have created here a fancy web-based ticket system. And if we use the network tab within our browser and do a reload here, and we see, make it a little bit more bigger, within the content security policy, that is the response header right from our web server, we see that every request should upgrade it, or every insecure, that means every HTTP request gets upgraded to the SSL version. Then we only trust the connection source, our origin itself, and another origin for UI assets. And you can use for images a wildcard here. So that means the content security policy don't care about the origin where you load images from. To give you an example, let's use here JavaScript or JavaScript to fetch something from http.org. And we hopefully see that we run here and an error, and you see here directly the content security policy says, okay, the page is blocked, and no request was sent to that origin. So that is all what I at the moment say about the content security policy. So enough terms, enough theory. Let's jump in our background story. And let's say our company has introduced a new web-based ticket system. That is the funny thing that you have seen so far here. Then in a future release, we want that the content of a ticket can be HTML for styling and convenient reasons, whatever. A user can create a ticket, an administrator can see and obviously can also create a ticket, but you see we have here the indicator that we have two major roles in the system. So let's call it the user role and maybe the administrator role. That could maybe here the goal to escalate or to impersonate an administrator. The system has checked and approved by the IT security, so why not? Everything's fine. We have seen the content security policy, which is said. Then the web application itself, by the way, is written in Angular. Angular itself in this framework has a huge and a really, really great XSS mitigation. Everything's fine, right? Then we have also the fact that external employees, so sometimes you work in project with external developers, for example, are also able to open a ticket. And now the fact is here that, let's say we are one of those external developers and we are super pissed because the reason that we have still some invoices open. And now we try to exploit or hack into that ticket system. So why not? But facing all the previous facts here, keep in mind with the content security policy, everything is checked by IT security. We use Angular in the front end here. What should go wrong? May ask yourself. I can spoil a little bit. There is something that can go wrong. So I would say let's jump in here by investigate a little bit. At first, let's log into the system with the ticket user, the password, and adjust the stuff here a little bit. So that is the create ticket card, so to say. And you have seen we can enter a title here, some fancy title, and we can enter a summary here. And if you remember back to our background story facts, that we want that the content, that's the summary field here, should be able to allow HTML input. So that it's the crucial information here. And the summary is that field. So that means we can add here some HTML. And then let's create a ticket, and you see, okay, the ticket was successfully created, so that's fine. And the administrator will check, okay, maybe let's see if we can look at the ticket. Oh, this was maybe not the right URL. So that could be an indicator that we as a normal user maybe cannot access the ticket after creating it. So let's do some information gathering within the application here. And let's get the main here. Let's beautify it a little bit. Then with strgf, start our search here in the front end code, and we see first hint here that there is an admin role, so to say, and there is something stored in the session storage. So let's see if we can check more, or maybe can find more about the administrator. Here is kind of our service and can activate. So for every Angular developer, you should see directly that is kind of activation guard in the Angular router. And you see we have the admin and ID. So that means we should kind of have here admin and an ID to access a ticket. Yeah? But you have seen at the moment that we have not the suiting access rights to do so. So let's jump back here to the ticket. What else can we see? We've seen something was loaded from the session storage. And if we investigate it here, we see here is kind of an access token, and here's the role, the user, and here's the token duration. It's around about one hour. And that it's hopefully our entry point in that application. But let's investigate that component here a little bit more. So let's jump back here in the debugger and in the code explorer, and let's look for something like the summary. And we see we have the crucial line here. This is the load tickets, and that gets from the router here, and that it's the crucial or the critical line of code here. Yeah, and here the developer team, to be honest, they had the requirement to allow HTML, and they had fulfilled that requirement here. Yeah, they had said, okay, please, the sanitizer from Angular, please bypass your security configuration and trust each HTML that is provided here in that summary field, because we have a strong content security policy, and with the sanitizer you cannot directly write some script text here that gets sanitized, or every kind that looks like JavaScript gets sanitized here. So hopefully you have a short idea what we can do now. Therefore, I have prepared a simple, let's say it, an exploit flow diagram. So let's start with the attacker, and the attacker here that are we at the moment as the external developer. So we are already with step 1 logged in, and we have created a ticket at the moment without the HTML payload, but we do that in a moment. Let's have a few seconds theory here. Then hopefully after creating the ticket, an administrator gets logged in, then view the ticket, then the HTML with the payload gets executed. That is step 2. And then in step 3, we kindly need to craft a piece of JavaScript that extracts something from the session storage, encode it a little bit, and send it to a third-party origin. Because we need a way to transfer the stolen the stolen JWT token around. And then I've miscounted, so that should be step 4, not 5. We need kind of an HTTP logger, or you can call it a webhook. I'll show in a couple of minutes what it is, which logs to, for example, a standard out or to a file where we as an attacker have access, and where we can copy and paste the token and impersonate the stolen admin token here in our session. And after that, we should have successfully impersonate the administrator. So, and one side note about the administrator here, you see that 5 to 10 seconds an administrator will open the ticket, and I've coded here kind of an automation in the background. So that means in the background There's a Dockerized backend up and running, and there's also a Selenium hub. I think it was a hub up and running, where a headless Chrome is or simulates the administrator behavior. Yeah? So that means after creating a ticket here, in the backend there is a job scheduled that will start right after 5 or 10 seconds. I'm not quite sure what the exactly number of seconds was. And then it's kind of a real user, open headless Chrome, logs into the system, and behaves like a real user. But we have still the problem that we have seen so far, that we cannot directly fetch stuff here or interchange data with another origin. Regarding, if you look back into the content security policy with the image wildcard here. So that it's the crucial, let's say it's the configuration flaw here. So, but before we start crafting the payload, I'll show you my short logger here. So that it's the system in the back, that it's up and running, where I can send data. So for example, if I send with curl to the logger the test param, I see here, right on the standard out, the stuff that I've sent so far. And that was the thing that I mentioned, or I meant with a webhook. But there are access services outside that you can simply use for that. Let me quickly check. Free webhooks, for example. So for example, this is a provider. He gives you a unique endpoint where you can simply with post or with get requests send data around. Quite easy. So let's have a look at the payload that we need so far. So of course we need to rethink a little bit of kind of a multi-stage. I've already prepared the stuff here, but we go together through that stuff line by line. So let's start with the raw JavaScript. So the first thing is we create a new image element within the I variable, and then we say, okay, the source attribute, that means the image source attribute where the browser should look for the image, is a special URL here. And that URL is from my logger that you have seen so far, and with the data or URL data param here. And then we simply append base64 encoded the string that we get from the session storage. So for example, if we do some JSON stringify, that simply, I think it converts an object, a JavaScript object to a string. And let's get rid of that syntax error here. You see we have that kind of a string, and you see maybe that backslashes and other special chars are a problem if you try to submit that by URL. So therefore we need to base64 encode those information. And after doing so far, you see we have that URL save params, and we can send that around within a get request within a URL param, for example. So that is how we craft the malicious image element. So after that, we need to append the newly created HTML element to document body, so that the browser start executing or start evaluating the element, and that it's doubled here, so we can get rid of that. And we need still kind of an entry event triggering, because we are not allowed to directly write JavaScript into that summary field. So therefore we can again craft an image element here, give it a source, for example, ASD, yeah, that doesn't exist, obviously. During the fact that the image source is not available, the on error event gets triggered. And here you see I have simply shrink the whole payload here into a one line, where the JavaScript that was defined here will get executed in the on error block. So hopefully that is working. So let's copy and paste that former created ticket ID here, so that we can later prove that we hopefully in administrator. Then we need our logger. Place it here on the right side. Make it a little bit more smaller. Then let's use our payload here. Then give it a title with tests and copy and paste the payload here. Then we create a ticket. Then we see, okay, the ticket was created, and now we need to wait after an administrator. Yeah, in real life, that could be whatever, 1 or 2 days, I don't know. Yeah, but within our automation, hopefully in the next couple of seconds. And you see, everything has gone well so far. So we see we have that base 64 data stream here. So let's copy and paste that. And then let's directly base 64 decode the stuff here. And I increase the font size. And you see I have simply piped the base 64 stuff into the base 64 minus D. And therefore we see the token duration, the access token, and the crucial information is that the role was from an admin user. So let's simply copy and paste the stolen token, open our browser's developer tools, go to storage, the session storage, get rid of the old token, just copy and paste the new one, yeah, the stolen one, and let's also change the role to admin. Let's refresh the page, and we should still see that we hopefully an administrator. Let's create a new ticket with test, get the ticket ID, copy and paste it, and we have seen that there is the admin pane. Let's copy and paste the ticket ID, and hopefully we see a view like that. And now we have successfully exploited or impersonate an administrator here. And by the way, that was one of the SecurityValley XSS or CTF challenges. And that is all for the moment. So to recap a little bit, what have we done so far? We have circumvented an okayish, let's say, content security policy. So why it should not be allowed to load images from any origin. Think of kind of a social network platform, whatever, I don't know. Maybe that is a real summary. And we have used that fact, and the fact that in the summary field the developer have trust the input or the HTML input, and combine all that together, we were able to create a payload. And in the end, our payload has successfully transferred the JWT token to our attacker's third-party origin. Then we could simply impersonate the token by adjust our session storage, and then we have impersonate the administrator user. So time for an outro. Again, here are ways to get in contact with me or to exchange further. And I hope you had understand a little bit more about the risks of the cross-site scripting attacks, and that not either Angular or some policies prevent you for running in a bad state, yeah, or get exploded. So thanks for watching.